A linear inequality is an inequality that can be written using two variables. This is like the solid or dashed line where we shade on the coordinate plane. First thing we're going to talk about is checking solutions of inequalities. So we have this inequality 2x plus 3y is greater than or equal to 5. And we need to know if the point 0, 1 is a solution. So what we're going to do is substitute 0 in place of the x and 1 in place of the y, and then see if it's a true statement or a false statement. So 2 times 0 plus 3 times 1, and we're going to see if that's greater than or equal to 5. So that's 0 plus 3. Is 0 plus 3 bigger than 5? No, it is not. So this is not a solution. Let's try B. 2 times 4 plus 3 times negative 1. 2 times 4 is 8. Negative 3. We've got 5 is greater than or equal to 5. Because it has that or equal to, yes, that is a solution to that inequality. So I want you to pause the video and try C on your own. And we find that yes, the point 2, 1 is a solution for that inequality. Now let's move on to graphing. First, we're going to look at Hoy and Vux. Y is greater than 2. This is a Hoy, a horizontal line. When you have y with no x, you're talking about a horizontal line. So this is a horizontal line at 2. So we find 2 on the y-axis, and we need a horizontal line there. But before we draw the line in, I want you to think about, should this line be solid or dashed? If we have either of, sorry, I don't know why Cortana popped up. If we have greater than or less than, we want to do a dashed line. If we have greater than equal to or less than equal to, we want a solid line. And I'll explain why in just a second. So this is greater than, we want a dashed line. And now we talk about shading. Y is greater than 2. Where are the y values bigger than 2? They're at 2 here, 3, 4, 5. They are greater than above this line. So we would shade in above this line. And if you like using colored pencils or highlighters, this is totally the section for you. Now, why did we use a dashed line? Y has to be bigger than 2. We want to shade the stuff that's bigger than 2, not including 2. So the dashed line is like a boundary saying everything up to but not including this line. A solid line means that the shading includes that line. It's the same as like open circle or closed circle. So dashed line would be the same as like an open circle, solid line would be the same as a closed circle. Okay, x is less than negative 1. This is a vertical line situation. So we're going to do a vertical line at negative 1. This one is dashed because it's just plain less than. And it's a good idea to put those little arrowheads at the end. X is less than. So right here, the x value is 0, 1. Those numbers are not smaller than negative 1. That's not the side we want to shade. Over here, negative 2, negative 3, negative 4, those numbers are less than negative 1. So that is the side that we want to shade. So we're going to shade over here on the left side. And your shading doesn't have to be super, super fancy, just so that we all know which side is shaded. All right, number 3. There's several ways that we could graph this. The easiest thing to do is to rearrange this into slope-intercept form, because then it's easier to graph the shading. So we are going to start by subtracting 4x on both sides. That gives us 2y is greater than or equal to negative 4x plus 8. Then we divide everything by 2. Y is greater than or equal to negative 2x plus 4. Okay, we're going to graph the y-intercept. Our y-intercept of 4 goes on the y-axis. Our slope is negative 2. So from this y-intercept, we move down to right 1, down to right 1, and so on. Okay, this is greater than or equal to, so we are going to use a solid line. And I'm going to try to get my ruler up here so I can get a nice straight line here. Okay, solid line. Okay, for shading, our Y is like the shaded stuff. The shaded stuff needs to be bigger than this boundary line. Our Y values need to be bigger than they are on the boundary line. So I like to look at this Y value. This Y value is 4. Where are the Y values bigger than 4? 5, 6, 7, 8. They're bigger up here. So that's the side that we need to shade. So some people say like shade up, but when you're talking about a slanted line, it can be kind of difficult to see what does shade up really mean. So you have to kind of think about where are the Y values bigger. So put your pencil anywhere on the line and draw a line straight up, or draw an arrow straight up from that point, and that'll show you where the Y values are bigger. All right, our next one. We would start by subtracting 3x on both sides. So negative y is less than negative 3x plus 3. That's a positive 3x, so we had to subtract 3x, but that left this negative y. To get rid of the negative, we have to divide by negative 1. And because we divided by a negative, it's going to take that sign and switch it. So y is greater than positive 3x minus 3. Our y-intercept is negative 3, so we're going to start at negative 3 on the y-axis. Our slope is positive 3, so up 3 over 1. Right. Okay, what type of line do we want to draw in here? Do we want to draw a solid line or a dashed line? We want a dashed line because it's greater than. So I'm going to draw in a dash. Greater than, so we shade up, we shade bigger. So I like to put my pencil on the y-intercept. Right here, the y-intercept is negative 3. I want y values bigger than that. Negative 2, negative 1, 0. That's the side of the line I want to shade. I want to shade up here. And again, your shading doesn't have to be super neat as long as you know which side of it is shaded for you. You have $200 to spend on CDs and music videos. CDs cost $10 each, and music videos cost $20 each. Write a linear inequality in two variables to represent the number of CDs X and music videos Y you can buy. So we can do $10 times the number of music videos, times the number of CDs. $20 times the number of music videos. We're going to add that together, and we have a limit of $200. So this is how much you are going to spend, and 200 is your limit. Can we spend more than 200? No, we cannot. Can we spend less than 200? Yes. Can we spend equal to 200? Yes. So our inequality is 10x plus 20y is less than or equal to 200. Okay, to graph this, we could rearrange that inequality to make it in slope-intercept form, but I think that using intercepts might be easier here. And I don't think we can buy negative CDs or negative music videos. So I'm going to make the origin, oops, that was really not straight. I'm going to make the origin be this lower left corner. And remember, X is the number of CDs that we can buy, and Y is the number of music videos that we can buy. So if we buy no CDs, if we buy 0 CDs, we've got 10 times 0 plus 20y is less than or equal to 200. Divide that by 20. 200 divided by 20 is 10. So that means our y-intercept is 10. So we count up here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could buy 10 music videos, and 0 CDs. Let's try this the other way. I want to know how many CDs I can buy if I buy 0 music videos. Divide by 10, we get 20. So, I don't think I can fit 20 here. I might have to count by 2s. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then I will connect those, and because it's less than or equal to, we can do a solid line. I really want that to be like 46 maybe? No, 49. Sorry, I'm trying to get my angle right for this ruler. It's gonna have to be close enough. Go. All right, now we can buy 0, we can buy 2 CDs, we can buy 3 music videos. The shaded stuff is going to be inside this triangle. Okay, my shading is going to overlap a little bit just because my highlighter is so thick. All right. It says also to discuss 3 possible solutions for this real life situation. Basically, what are 3 possible combinations that you could buy? Like, here's a point right here. This point is 8, 1, 2, 3, 4, 5. 8, 5. This means, I probably shouldn't use equals. This means we can buy 8 CDs and 5 music videos and still be within our $200. This point right here means that we can buy 2 CDs and 8 music videos and still be within our $200 limit. We could also look at something like this right here. We could buy 28. That's 16, 2. We could buy 16 CDs and 2 music videos, and because that's right on the line, we would end up spending exactly $200 if we bought that combination. So this graph is just a visual representation of how many CDs and music videos we can buy to be within that $200 or exactly at that $200.